The next part of our lesson for today is how to use the Pythagorean theorem to prove that the three given sides of a triangle makes that triangle a right triangle. So if we substitute these values and we get a true statement, then we do in fact have a right triangle. So let's look at this first example. Notice that we don't have that right angle marked anywhere. Just by looking at this, I would figure if this were a right triangle, the right angle would have to be down here on the right hand corner. But we don't know for sure yet, which is why we're using the Pythagorean theorem. So since it doesn't matter which value we substitute for A and B as long as they're both legs, the most important part to identify first is the hypotenuse. And remember that the hypotenuse is always the longest side in what would be a right triangle. So in this case, we can assume that 15 may or may not be the length of the hypotenuse. I say may or may not be because we're still testing these values in the formula to see if it actually works out to be a right triangle. So the first thing we'll do is write down the formula. A squared plus b squared equals c squared. And we're going to substitute our two legs and our hypotenuse. So again, the hypotenuse is 15, and 9 and 12 are our two legs. So now we're just going to evaluate and see whether this equation is actually true. So 9 squared is 81, 12 squared is 144, and 15 squared equals 225. So remember, if the sum of the smaller two legs, the area of the smaller two legs adds up to the hypotenuse, then we have a right triangle. And in this case, 225 is equal to 225. So yes, it is a right triangle. Let's look at one more example before you practice the third one on your own. So as we did in the last example in number 1, we're going to write down the formula for the Pythagorean theorem, and we're going to substitute the two legs and the hypotenuse for A, B, and C. So for our two legs, we would have 9 and the square root of 115. So it'll look like this. Make sure that you write down that square root symbol as well, is equal to 11 squared. So now notice what happened when you square a number that has a square root symbol. As a side example, just to understand what happens when we square a square root, take a look at what I'm about to write in purple. So let's say we have 5 squared. So 5 squared is 5 times 5, which is 25. If I ask for the square root of 25, then the answer will just be 5. But now if we're squaring what we already have under the square root symbol, it just cancels each other out. So when you square a square root, you just get whatever you have inside of the square root symbol. So the square root of 115 squared is 115. So we have 81 plus 115, which gives us a sum of 196, and that is not equal to 11 squared, which is 121. Therefore, in this case, the three sides that we're given do not form a right triangle. So we've used the Pythagorean theorem to prove that these three given sides would not give us a right triangle. Take a look at this last I hope I did that fast enough. Take a look at this last example in number 3. Remember, the hypotenuse is the longest side, and unpause this video when you're ready for a solution. So after substituting the two legs, 9 and 12, and our what would be, assuming it's the longest side, in a right triangle, our hypotenuse, we get 225 equals 289, which is false. Those two numbers are not the same. They are not equal. So we do not have a right triangle. So take about 30 minutes to work through the examples in your handout. Notice that sometimes when we use the Pythagorean theorem, we end up with nice values that result in whole numbers. So for example, when we look back at guided practice number 1, in this case we have a 3, 4, 5 triangle. And a 3, 4, 5 triangle is a Pythagorean triple. In example 2, we have a 5, 12, 13 Pythagorean triple. And the last one, we have 6, 8, and 10. So some examples, will have a result that's a decimal value. So one thing to take note is that when we have a number that's not a perfect square number, for example, the square root of 8, this is an exact value. So let's say we were solving for a missing side, and our last few steps we had 8 is equal to c squared. The value of c, or the hypotenuse in that case, the exact value would be the square root of 8. So in some cases you'll be asked to find the exact value, in which you'll just leave the square root symbol, or you'll be asked to round. So the square root of 8 rounded to the nearest tenth is approximately 2.8. So this is an exact value, and this is, let me make that decimal bigger, this is an estimate or an approximation if you're asked to round. So half an hour to finish up classwork. In the afternoon hour that we meet, after you've completed your classwork for the day, you will receive a homework handout, and that homework handout 6.01 will be due tomorrow. So we are no longer finishing our classwork as homework. Your classwork will stay in class and go inside your class binder, and your homework will just be one sheet front and back, probably about 6 questions each day for you to complete either in class when you have time or for homework. Have a good day.